Next we've got David Whale, and he is presenting Bitio.
Thank you very much, good turnout. Hope everybody can hear me at the back. My voice is going already, I'll try and speak up. Okay, so I've done a sort of who, what, where, how, why, when of Bitio. So I'll start with the who. Fun little photo. I found this on my Twitter feed the other day. This was from April 17th, 1986. I was 17. This was a picture of me as a child writing computer programs for the school for a library computer program. I've been coding since I was 11, so working with a microbit has been quite exciting. It's been like being an 11-year-old again. What I'm going to talk about is Bitio. And the idea is that it's a way of getting the microbit and another computer working together in Python. And I'm going to begin some demonstrations. So my name is David Whale, I'm Whaley Geek on Twitter. I'm an embedded software engineer by trade, so I've written lots of code that goes in lots of electronic products you might have in your house. I learned to code when I was 11. I was a school STEM ambassador. I do a lot of work in schools. I go into computer clubs. We have a Pi Wars team that goes into Cambridge Pi Wars every year. And I've done lots of teacher CPD, teaching teachers how to teach Python. I also worked with someone that might be at the back there, Martin O'Hanlon. Gives a wave, Martin. And we wrote a book called Adventures in Minecraft. And I'm not particularly promoting that here, but here's a picture of it just in case. But the reason I wrote Bitio was to do something new with Adventures in Minecraft. And I currently work for the Microbit Foundation, and my job title is, interestingly, Wizard. Zach, our CEO, has quite a fun nature and tries to find fun job titles of people. So basically, I write teacher resources, I write projects, I'm having fun basically. So. Okay, so what is Bitio? So Python all the way. So I need to do a little demo here. This is where the Mac has trouble with projectors. Right, let's have here's an item showing. Regrade 3.6. Okay, so we've got a little program here. Everyone cross their fingers. This is demo mode. Connecting. Microbit is now running. Okay. So on the screen, so basically what I've loaded onto here is MicroPython, and the Mac Python is now talking to MicroPython by sending the commands. You might see that the lights on the back is just flashing because it's constantly holding the device. And it's basically reading to see whether there's any input-output events. Sound. Ready. Okay, press button A. So button A basically just says on the screen, you press button A. Now what's happening is the code is running on the Python on the Mac, it's talking to the microbit and it's sending the event back to say that you press button A. So without changing the code on the microbit, so I just write code on PC, Mac, Raspberry Pi, in normal Python, I can access all the sensors on the microbit.
Please do not press that button again.
That was button B.
Please do not press that button again.
Okay. Now the microbit has makey style sensors on it. So in theory, oh, I'm using the wrong banana. This is my banana. This should have been Rachel's banana. Let's try it out.
5, 4, 3, 2, 1.
And it basically says on the screen, bang. So I've used the touch sensors. I actually need a volunteer now because I've got some extra code on pin 1. So can I have a volunteer, please? Someone? Yes? And there's a force trigger in it. So it's resistive touch sense. So if you hold that with one hand, so actually hold the metal bit and then touch the banana.
5, 4, 3,
And it now says boom on the screen. So the only code that is running on the micro:bit is MicroPython. So it's just, if you saw the talk from Nicholas earlier on about mu, so it's using the Python REPL, the read, evaluate, print loop, sitting there as a terminal prompt. And what the program on the Mac is doing is it's typing in commands. Okay? So what this means is, if I want to change what happens on the micro:bit, I don't have to keep flashing the code to it. So I can now focus on the Python code that's on the Mac, PC, or Raspberry Pi. So the reason I was a little bit late coming in was I was briefly called into a workshop that was going on in the Raspberry Pi room, and Kat Lehman came over and says, there's some kids in here, they want to do something with accelerometer and Minecraft on the micro:bit. So I just gave them a copy of Bitio and explained how it works. So hopefully there's going to be a little show and tell there later on, where they tilt their micro:bit and Steve moves around in Minecraft. So we'll see what happens. There's a little bit of automation here as well. So what happens is, when you first plug the micro:bit in via the USB, when you first run the Python program, if it doesn't know where it is, it will do a search and it will find the port for you automatically. See if I can. Here's me. So that's the simple demo. Slideshow. The mouse disappears. Current slide. That's good. Okay, so that was the simple demo. So button A, button B, touch the pin. So at the moment I've implemented about 3/4 of the Python API on the host side. So you can do pin touch, you can do button A, button B, you can display images on the screen, you can scroll text on the screen, you can use the accelerometer as well. So over to the why. So the whole point was, I had this issue that I was trying to do Minecraft with Python to write a book, and wanted to bring some physical computing in. Now, something you can do really, really great on the Raspberry Pi is physical computing, because you have those I/O pins and you plug in various cards. When Martin and I spoke to our publishers, they said they wanted the book to be written to run on as many platforms as possible. And we went through and we thought of all the platforms that, well, PlayStation can't do it because there's no programming interface we can get access to, Xbox, forget that. We can do Raspberry Pi because it comes free with Minecraft. Martin came up with a way of easily packaging the Python that we needed to get Minecraft working with Python on Linux, Mac and Windows. And I then thought, well, how do we get electronics in? So I wrote a little package at that time. It was called NEIO. So it was like GPIO for Raspberry Pi, but it had a little Arduino board plugged in. And the idea was that if you was on the Raspberry Pi, you would use our Pi GPIO, and if you was on the Mac or the PC or Linux, you would use NEIO.GPIO. And the functions that you call are identical. And this is good when you're writing a book that works on 3 platforms, because you don't have to write the same thing 3 times. So apart from a few different screenshots of the wiring, we can say the code is pretty much identical, so we don't have to write the code once. That means rather than the book being this thick, it's this thick. We put more challenges in it. This went really well, so we got some people buying our books, and a number of those people got into doing some physical computing with Minecraft and Python on Raspberry Pi, PC and Mac, which is good, so more platforms. And then I had a message from, if anyone knows, Ryan Walmsley from Ryan Tech. So he said he had an idea of doing a plug-in board that works with Raspberry Pi hats, that plugs in via the USB. So the things that you do on Raspberry Pi, you can also do on PC and Mac. And he looked at NEIO, he said, that's really good, can I use it? And he did a very successful Kickstarter campaign, RTK.GPIO, which is the same sort of basic idea. He did really, really well, but when we were speaking to Ryan about whether to use this for a book, he was unsure as to whether he was going to go forward with it or not. Here's a picture of the wiring using an Arduino. So if you don't have a Raspberry Pi but you have a PC or Mac, you might want to use little Arduino platforms, and this was something we did for one of the games where you basically press the button and then you get the countdown on the LCD LED display, and then you get the big explosion at the end. And what we decided to do for the new edition of the book was we wanted a platform. These are okay, but they're a little bit hard to get hold of, and so it would be really nice if children could go into a shop and they could buy a book, and they could also buy off the shelf the electronics to do it. I thought, well, what platform is out there that runs off the same voltage as the Raspberry Pi? We can program it in Python, we can plug in bits of electronics, it's got some buttons on it. The MicroPython might be a really good idea. So, for anyone that's got the first edition of our book, as of, I think it was a couple of days ago, the electronics chapter, which is all the challenges you can do with that electronics or with the Raspberry Pi, is now released for free on the internet. So if you go to the book's webpage, you can now just download the PDF for that chapter. Where this really started, though, was that Martin and I had one of our famous Twitter conversations where we were talking about something, and I said, oh, you could do so-and-so. And actually what it means is, Martin, you could do this, couldn't you? And I said, you know that amazing 3D simulation of Star Wars that you did at one of the Raspberry Pi birthday parties, where you flew an X-Wing? Well, maybe we could use a microbit, and as you tilt the microbit, you move the X-Wing around inside Minecraft. And true to form, Martin, given a challenge, he did it, and it's available on YouTube. I won't play it now, it's a bit shorter time, but you can tilt the microbit, and it sends little messages over the USB port, and it controls this X-Wing fighter inside Minecraft. And that's what then got me thinking that, well, that worked, but he had to write a piece of custom code for the microbit. So to get this working, you need to write a bit of code for the microbit and download that. And then you need to write the code on the main computer for the Minecraft. And then if you change it, you've got to reflash the code and everything. It would be nice if you just do all the Python coding in one place. So this was the idea of Bitio, that you could do that. It's enabled the second edition of our book, so that's a bit early. So a bit into the technology now. So how it works is it's just like inside New, where you can open a Python shell and type in commands, and they run directly on the microbit. So there's a thing in MicroPython called the REPL. So it will wait for a piece of Python text to come in. When you press enter, it will evaluate it, it will print the result and loop back around again. Now that's quite hard to drive from a Python program, because there's all sorts of different error conditions that can happen there. Now fortunately, Damien George, who wrote MicroPython, he included a facility called the raw REPL. And what this is it's a version of the Python shell that is written for computers. And a lot of the tools that come with MicroPython actually use this to flash code and to install packages and things. So it's just written in a slightly more cleaner way that you can write a computer program that remotely controls MicroPython. So the package that I've done is zero install, so you just take the files. I proved it about a few minutes ago. I had a memory stick and I went into the workshop that was there and I said, oh, copy this package on your machine, import microbit, and then suddenly they had the micro accelerator working. So it's great for schools because you don't have to, you don't even have to be on the internet, you can just have a copy on the memory stick. It automatically detects which USB port the microbit is in. And again, this is good if you write in a book because you don't want to 3 times say, on the Mac you go to this screen and click here, and here's how you find the COM port number. And on the Pi you do it this way, and on Windows you do it this way. So it automatically detects which USB port the microbit is plugged into. And it uses, under the bonnet, it uses a version of Pi Serials, which is a library for sending messages over serial ports, and that's built in as well. So there's a packaged version built inside the package. And again, that just makes install really easy, and the licensing Pi Serial allows you to do that. You can find this. I'm being harassed by Josh at the moment to put it in the PyPy index. I will do when it's completely finished. You can get it from GitHub. I'm hoping that we get onto Wi-Fi here and do a couple of demos of people that have done things with Bitio. Bear with me, I'll turn the hotspot on. moment of truth when you see the little icon. Right. There we go. So, okay, so there's a teacher, thank you, there's a teacher in school who teaches with Raspberry Pi and Python and MicroPython, and he used to work for BBC Radio. And his go-to project when he gets a new piece of technology is to build a radio or a radio station. So hopefully, Charles will say
I'll show you a radio that I made. It's not for position technology. It's can I make a radio with it? What I've got here is a Raspberry Pi computer and a BBC microbit. Thanks to David Wales, Bitio in library, it's really easy to get readings from sensors on the microbit, such as the accelerometer when it's tilted, button pushes, touches, all that kind of thing, and use them in Python programs. It's really, really simple to do. So it took me about 10 minutes just to knock up a very, very simple radio. Here's how it works. I run the code on here, so I run the Python code that I wrote, and we should see, scrolling on the display, it should say radio rocks, my radio rocks. And then it will start playing the first of 4 stations that I programmed. You can control the volume by tilting the microbit. If I tilt the microbit to the left, the volume goes down. If I tilt the microbit to the right, the volume should go up. And I'll tilt it back down again. You can control the channel by pushing the button. So if I push the B button, it goes up the channels. That's channel number 2. This is going to flickering a bit on the video, but really good just in real life.
So basically, this is quite exciting because what Giles has done is he's taken a whole load of projects that he's done on the Raspberry Pi, and he said it would be great to have some form of external controller. So one of the things I'm adding to Bitio at the moment is the radio module. So if you imagine doing this, where you have the one microbit plugged into the Raspberry Pi, and then it's sending radio messages, and then you're actually walking around the house and you've got a second microbit and shake it to change channel, or tilt it to turn the volume up, and so on. It'll be quite exciting. The other one that's worth mentioning briefly before I run out of time is so Chris Penn, NCS Computing, which Commercial Raspberry Jam. He had a load of projects that he'd done in Minecraft and Python on the Raspberry Pi, and he saw this and said, oh, this is fun, and basically he took all of his projects and he added microbit support to them. So he's added the Getting Started guide. This is great actually because I've got some documentation to write, and he's written a whole load of blogs about it, so it's made the documentation a bit easier to write. So Getting Started, he's done all of the standard things, so like the Rainbow Road. So he has so again, this is using the microbit as a controller. So a standard piece of code you write in a workshop might be, as you move Steve around, it leaves a trail of random blocks. I think this might even be one of Martin's original ideas. So now instead of pressing keys on the keyboard, you can use your microbit and you can tilt it. But if you decide that you don't want to tilt your microbit, you want to touch a banana, and then touching the banana changes the colour of the Rainbow Road, you can do that by just changing the Python code. So it really is Python all the way. So we've got Python on the Raspberry Pi, Python on the microbit, and the code works the same. I think that was the one I was going to show. Oh, there's one he did where we read the temperature using the temperature sensor on the microbit, and then he started to build graphs. So I think I can't remember if it's the height or the colour changed as temperature changed. He was touching the microbit on his cup of tea and getting the graph to go up and down. So again, great for little science experiments. And if you imagine, so when I add in the radio support, being able to do like remote experiments where maybe you have a Raspberry Pi in the centre of the classroom, taking a whole load of measurements and microbits, and you might be running around attaching microbits to the radiators and the windows and taking all sorts of measurements, and actually you're writing Python code all the way. So it's a really, really good way of getting the two devices working together. So we love microbit, we love Raspberry Pi, we love Python, we love Minecraft. All of those mashed together works really, really nicely. That's pretty much what I wanted to go through. If anyone's got any questions about the idea or any ideas of things we might do to improve it, please do go ahead. Thanks so much. Any questions? Johnny, I know you've got a question. You must have a question.
I haven't got a question.
Johnny's always got questions.
Perfect.
Thank you.
When's it? Are you here on the sprints? Can we do the radio stuff on the sprints on Monday?
I'm not here on the sprints, but the code's in GitHub, so if anyone would like to have a go at adding some more support to it, that'd be great.
Yeah, so the MicroPython is here for the sprints. If people want to come and work with it, with Bitio, we'll be around.
Great. So there's so I've got touch pin support, button support, images are in there. I haven't yet added in the wrapper that makes the speech engine available, but that's another one that would be quite good to do. There's not a lot of code in Bitio actually, it's just a little wrapper, so basically you expose a function inside the microbit class. And what that does is basically sends over the raw record the commands that make that happen on the microbit, and then it waits for the response to come back. So if we wanted to make it, so instead of having to use the speaker on my Mac to do 5, 4, 3, 2, 1, we use the built-in lovely speech engine that Mark Shannon put in there for us. That would be a good one to do. I haven't actually done digital input and digital output yet, mainly because all I needed for the book was touch pins. But there's, again, a few little lines of code that need adding there to do that.
I have got a question now. What if I want to plug more than, like, if I want to plug 4 microbits into the 4 USB ports on a Pi and have them all doing different things, does that work?
Not at the moment, but it might be a nice thing for a sprint, yeah.
Yeah.
It's mainly to do just how you manage the ports.
Yeah.
I mean, there's an individual Python class that manages that instance of the microbit. It's more to do with how it does the searching for the port. So because basically you say import microbit, there's only one microbit instance in memory at the time. So how you import it might need to change, so you have more than one copy of those inside the program. Yes, no question.
This might be a stupid question. I'm not sure on the hardware details, but have you got plans to do the sort of Bluetooth linking? Can you do that in Python to say link to a microbit of Bluetooth?
So in this particular build of microbit and MicroPython, no. The Bluetooth memory requirements are quite high and quite challenging to get MicroPython and Bluetooth in there at the same time. There is some work that, it was Wayne Keenan was doing some work to get a version of MicroPython with Bluetooth working. And I think what he'd done was he basically implemented a very small number of the Bluetooth APIs, so you could just about get Bluetooth functionality. So that might be a way of doing that, and then use Bitio. But what I tend to do when I use radio communications with MicroPython is I'll have one microbit plugged in by USB, and that acts as a radio gateway, and then any messages sent and received basically are sent up to the main computer, and then you do your remote sensing that way. It's probably technically possible if you find the right USB dongle with the right chipset in, you might be able to find a way of plugging in USB into the Pi and using the raw radio that way. But it tends to be just much easier just to plug a microbit in.
So if I had a second microbit that just sent everything it did over radio to that microbit,
yes.
then effectively I've done.
Yeah, and because the radio is effectively a broadcast network, so if you've got all those microbits on the same radio group and the same radio channel, then all messages would be shared. So Johnny's just left the room, but a project that John and I did at BETS January earlier in the year was we made a musical instrument out of 40 microbits called a tone matrix. Each microbit was a note in a 5x8 matrix, and then the 41st microbit plugged into the Raspberry Pi. We had a Raspberry Pi under the table. Sorry, carry on, so it was under the table. And that was plugged into speaker, and what that was doing was basically, depending on which microbits you turned on, it was looping around playing those notes. So you could play a pentatonic scale with 8 positions in the bar, and it was cycling around. And they were all basically sharing their state via radio. And then so the 41st microbit plugged into the Raspberry Pi was receiving any button presses to turn the note on and off. And then the Raspberry Pi was generating the timing, saying column 1 go now, column 2 go now. And then the microbits themselves would flash their display if they were enabled. So it's quite good. So it's like an interactive exhibit. You can actually change the music as it was going round. And we used PyGain on the Raspberry Pi to do the live sound mix. It's had 5 WAV files. And depending on which microbits have been turned on, it would mix the file and play the WAV file. So that's quite 41 microbits in one Raspberry Pi. It's quite a big project. It's on the blog somewhere. If you look at Microhorns, so Buchanka's Raspberry Pi pod blog, and search for Tone Matrix, you'll find a little video of John explaining it there.
That's about all we've got time for.
Okay, thank you very much.